So today we are addressing functional mitral regurgitation, which is essentially when your heart valve fails to work.
Explain to me the problem of mitral regurgitation.
When a patient has a heart attack, what ends up happening is this left ventricle here, instead of being like a football or helical, becomes like a soccer ball and more spherical. So now it kind of gets rounded, and now its ability to actually push blood is impacted. About 6.5 million people in the US have heart failure. 50% of them will end up with functional mitral regurgitation as a byproduct of that.
Lori, thank you for joining us today.
Thank you. Thanks for having me.
Yeah, absolutely. You've solved a couple different complex problems as a CEO of several different companies in the medical industry. What problem are you attacking today?
Yes, so today we are addressing functional mitral regurgitation, which is essentially when your heart valve fails to work appropriately. And so what that means is that normally you have two leaflets of your heart, and they come together to allow the blood to flow in one direction. But after a heart attack, in many cases, what happens is those valve leaflets don't come back together again. And so therefore, the blood now, rather than just going in one direction, it goes in two directions. So what does that look like? You might be short of breath. You might have swollen feet and ankles. You might have congestion in your kidneys or in your liver. And so you're sick. You might turn a little bit yellow from that. You definitely can't do exercise. So what ends up happening is over time, the longer this functional mitral regurgitation or secondary mitral regurgitation happens, the sicker you get. And so the sicker you are, the less likely that you can have surgery, because the definitive treatment for that is open heart surgery. But as you get older and you get sicker and you have more what we call comorbidities, which is impact on the liver, impact on the lungs, and that you don't do as well going under open heart surgery. So we have a device that actually delivers an implant through the femoral artery, through the femoral vein, in a minimally invasive procedure and repairs that functional mitral regurg.
Explain to me specifically and as simply as you can, the problem of mitral regurgitation.
Sure. So I'm going to use an example that I do with my hands, which I think really helps because it simplifies it. If you take your hands and you put them together, you can see that I've made a heart here. This is your heart. So if you look at the bottom of it, that's your left ventricle, and your left ventricle is helical in shape. So it looks like a football. That's what a helical design is. Up here, you have the two leaflets, right? Anterior, posterior leaflet. Every time the heart beats, the ventricle pushes the blood up and the leaflets open. As those leaflets open, blood is propelled out into the body, so it perfuses or brings oxygen to all the major organs. When a patient has a heart attack, what ends up happening is this left ventricle here, instead of being like a football or helical, becomes like a soccer ball and more spherical. So now it kind of gets rounded, and now its ability to actually push blood is impacted. But look what happened to my two leaflets. They are now pulled apart because as the heart goes like this, these get pulled apart. So now when they open and close, you can see the big gap in there. And now the blood, instead of just going in one direction outward to the body, it actually goes backwards as well. And so that's called congestion. So now it congests your lungs, which makes it shortness of breath. It congests your kidneys, and it congests your liver. So you get what's called ascites or fluid in your stomach. Now it also congests your extremities, your legs, and all of that. And so when we put the CARLEN on, it basically puts a bump on the end of the leaflet that allows it to close. And so because of that, what we anticipate now is that the impact of this being spherical as opposed to helical is going to be minimized.
The congestion, what sort of symptoms do people feel during that time? Do they feel it, or is
it? They feel short of breath. They feel it's exercise intolerance. Walking up the stairs, their heart rate might go up because it's trying to
regurgitation.
That's the regurgitation. Yep. So that, and you feel that in the congestion because all the fluid now just is living in the lungs, in the liver, in the kidneys, in the extremities. And so it's literally something as simple as you pick up a basket of laundry and you go to pick up the basket in turn and you go, you have to take a deep breath, or your heart rate might go really fast because your heart's trying to compensate. It's saying, oh, I'm not getting enough blood. Why not? Okay, let me increase my heart rate because now I'm going to try to beat harder. But I'm beating harder against this valve that's incompetent. So the blood's going both ways. So I'm not actually improving it. So
It's
your
getting
body,
worse.
it's getting worse because now if your heart rate goes up, you're asking for your heart to work harder, which means you need more oxygen demand, but all that oxygen is being consumed through this congestion.
So if you have these leaflets that are separated and this is just me trying to understand, if you have these leaflets that are separated and you're working out to try and undo any sort of sedentary lifestyle that you've already had, how does it come back together eventually? Because it sounds like, you're walking up the stairs, or
Right.
you're moving a basket of laundry and
Right.
you're short of breath. Well, the only way to fix that, unless it's only surgery, is that when it's gone too far?
Yeah.
Or is there any way to undo that?
There's no real way to undo that with exercise. No, you've got it because you have an anatomical issue with that valve. So what they do is they give you medicines. And what the medicines do is it helps move fluid away. So that's, diuretic. So you're peeing all the time because you don't want any extra fluid in there. You have a medicine that takes your heart rate down, so that your heart won't go up too high when it tries to compensate. It keeps it low because it doesn't want to put that much pressure on it.
But all of those sound like Band-Aids.
They're all Band-Aids. They're just a short period of
Don't solve
time.
any problem.
And the other thing with medication is that in studies with medication, if you're perfectly compliant, which means that you're supposed to take that pill every day, you're going to be okay. But the data suggests that patients are not compliant. Why? Great example. I'll use my mom again. She had to take a ton of diuretics because her heart wasn't working. So she had to take like 120 milligrams a day. A normal tablet's 10. So imagine, right? 12 times normal tablet. What does that make you have to do? Pee every 5 minutes. If you don't feel good and you're short of breath, are you going to get up to pee every 5 minutes? No. So what do? Don't take your medicine. So then you don't take your medicine because you don't want to get up to pee. But really what you need to do is take the medicine so you have the energy to do it. And it becomes this vicious cycle. So when we ask patients to rely on medical therapy, medicines are great and we should not, certainly poo-poo them. But I always say they're not free. And I don't mean by their cost. I mean that when you take a medicine, you have to be 100% compliant and you have to understand all of the untoward events that happen because of that medicine. So that's the challenge that patients face. And that's why we'd like to fix it. But are you going to fix it with a device that you don't have another option for later? So then patients are reluctant, right? So the current treatment, so doctors will wait longer and longer until they have no other options. So then think about the vicious cycle. The longer you wait, the sicker you get. So the likelihood of this working is going to get less. With CARLEN, what we believe is that we can augment or supplement medication. So they can take a few medications. We can put the device in earlier. We can extend the lifespan of this patient. And then we can intervene again if we have to down the road if their disease worsens. Hopefully they exercise and eat right and, do the things that they can control. I mean, all heart disease is within our control. Some of it's just hereditary bad genes or genes that are not, working well. But if you could, if you have bad genes, still put everything in place to optimize that.
Set yourself up for the greatest success.
Exactly.
Yeah, well,
Exactly.
I'm sold.
Good. So you'll get you one when it's ready.
Well, hopefully not.
Hopefully you won't need it because you're going to do
now.
your exercise
Exactly.
and walk up the stairs and park in the farthest parking lot.
Exactly. I don't know if I'll do that.
I know.
Yeah.
And you carry that baby carrier. That's all you need to do.
Yeah,
that gives you good exercise.
Yeah. So essentially the people that you're treating are people that have had heart attacks?
Yep.
Okay.
So right now, about 6.5 million people in the U.S. have a heart attack every year. And of that, 50% of them, have heart failure. 50% of them will end up with functional mitral regurgitation as a byproduct of that. And so those are the patients that we treat.
So 50% of the 6.5 million.
Yes.
6.5 million people have
So
heart attacks.
3.25 million will be the ones that will end up with functional mitral regurgitation. And the issue with it is it's an insidious disease process. So they don't notice it right away. So they've had a heart attack. They might have gotten a stent put in, they're recovering, but they don't seem to get better. And that's because the ventricle starts to go from looking like a football to looking like a soccer ball. And when it does that, it pulls pressure on that mitral valve leaflets and pulls them apart. And so once they get pulled apart, that fluid is allowed to go backwards and forwards. And that's when they start getting sick slowly over time.
And the random sicknesses is the only way to kind of identify that early?
Most of the time, yes. Oftentimes they will do echocardiograms. So the physicians will do echocardiograms and they'll watch it. They'll give them medications. So they'll give them generally like a diuretic. They might give them a beta blocker, like something that slows down their heart rate to make their heart beat more efficiently. And they'll kind of watch it. But generally speaking, like I said, it's just a very slow, insidious process of getting sicker and sicker. And so what we call activities of daily living, the ability to get up and do what they want to do when they want to do it, begins to become impacted to the point where they really can't do anything. And then we had a term back a long time ago when I was a nurse, we called those people cardiac cripples. And it was the point where they could not enjoy the activities of daily living because either profound shortness of breath, swollen in their legs and their feet, so their shoes don't fit them, so they can't go out and walk for long periods of time. And it's just all these little processes that end up making the patient just not feel good.
Wow. So if somebody's feeling these sort of things, if they're out there and they're like, wow, that sounds very familiar, they should just go to their doctor and see if it's this functional mitral regurgitation that's causing these.
And they can get an echocardiogram and they can look at the valve, they can measure the valve. And what they look for is what we call mitral regurgitation. Functional is the secondary, which means it's not an anatomical thing. It's actually a change because of this heart attack function that causes that. Could also come from having prolonged atrial fibrillation. So patients that have atrial fibrillation for a long time, even after you repair their atrial fibrillation, their ventricle might be working okay, but their valve becomes incompetent. And that's what we call it. Just doesn't work the way it's supposed to, and it allows the blood to go back and forth.
Okay. Taking a step back and letting people know a little bit about yourself, who is Lori Chmura?
That's a great question. Who is Lori Chmura? So I actually started my career as a critical care registered nurse in the cardiac field. So I always like to tell the story. I was brought up in a kind of first generation, post-World War II, post-Depression, Italian Catholic family back in the day where women didn't go to college or really do a lot other than you can become a nurse or you can become a teacher is essentially how our family looked at it. And so I had a choice, nurse or teacher. And no offense to teachers, but it just seemed nursing was harder. So I thought I would try that. And so I became a nurse and I loved it. And I worked at Yale New Haven Hospital. I was the first new graduate ever hired into the cardiothoracic ICU. And so I got to experience kind of a lot of firsts. So first time there was a stent ever put in a patient. First time there was a heart transplant. First time there was a heart-lung transplant. So I got to see a lot of firsts. And that got me incredibly interested in the whole innovation part of healthcare. Plus, I really had this acumen for business. My dad had a mechanic. He was a mechanic and he had a garage, and I would go to work with him every day in the summer. And I liked pretending like I ran the place. I pumped gas and I, did the cash register. So this kind of affinity for business and this, recognizing that innovation could help patients kind of got me thinking that I wanted to switch careers. So probably 8 or 10 years into being a nurse, I switched into becoming a clinical specialist for a heart failure company. So I started my career in the cardiac space. And then I went from clinical specialist to vice president of basically North America in 8 years. And then from there, I kind of built this career. I was really committed to not staying in cardiac because I felt like I needed to prove that I can do something else, but full circle ended up back in cardiac. So I kind of like to think of my career in 3 segments. First part was nursing. And then the second part was basically Fortune 500 companies, big companies. And then the third was kind of in the venture capital world of going all the way back, taking innovation, thinking about the impact on the patient and building something.
And so now you're in that stage, building something that's hopefully going to change a lot of lives.
Yep, exactly.
Out there. So tell me about the company that you're with now and what your role is.
Yeah. So right now, I'm the CEO of Nyra Medical. And so the company was actually founded out of Emory University. So our founder, Dr. Padala, was just, an amazing, intelligent PhD who did his PhD at Emory, between Emory and Georgia Tech, biomedical engineering. Actually started his career as an aeronautical engineer, and he started to look at mitral valve disease. And so he, dedicated his life to it. He ran a very prestigious lab at Emory. And what he saw, which was really fascinating, is he looked at these patients that I talked about, the 50% that got mitral valve regurgitation. And instead of looking at why they got it, he looked at why they didn't get it. He said, who is not getting this? And what are some of the characteristics of those folks? And so he was fortunate that he was able to establish the company out of Emory using NIH grants and what we call non-dilutive capital. So a way to kind of fund all of his work. And what he saw was that the patients who did not get mitral regurgitation after a heart attack had a longer leaflet, and there was some kind of a bump or something on it. And so what that did was it actually helped to maintain what we call coaptation, or the ability of those two leaflets to kind of come together to prevent that backward blood flow. So he designed and developed, in conjunction with his PhD students, an implant. It's made of nitinol, covered in polyester fabric, that we literally just clip one single leaflet of the mitral valve, and it restores that coaptation. So it's so simple that it's like this elegant kind of solution that when we talk to physicians, they're like, that's so simple. Like, why didn't I think of that? And
it's replacing heart surgery.
It's replacing heart surgery. So today there is a device on the market, and what it does is it does also transcatheter, and it goes in, but what it has to do to work is it takes both leaflets and brings them together. And it's based on an old surgical procedure that really wasn't that successful as a surgical procedure. And over time, it prevents the leaflet from working naturally, so the heart doesn't go into diastole. And if you remember your biology from high school, which I know you went to a really good high school.
We can test my knowledge here. Yeah.
Exactly. So the part which is really important in the cardiac cycle is the rest cycle, or diastole, which goes along with the bottom number of your blood pressure. And so when the other device is put in, it keeps the heart never from really going fully into diastole. So the native functioning of the heart is not working, which means your heart's never really resting. And so a couple of the phenomenons of that is, I think the data suggests that after 5 years of having this device in, 78% of those patients don't survive. And a lot of that is due to the stenosis that happens, and the progression of the disease.
And stenosis is...
And then also the concept that your heart isn't getting a chance to rest. So it's kind of always in this hyper state of systole. And so what this device does, our device does, is it's single leaflet capture. So from a complexity perspective, when the physician goes in, good reason to play video games, right? Because you're actually watching a screen and you're doing the procedure on the screen.
I have heard that video game players, it's like something like, what is it? No, surgeons that play video games are like 80% better. Or something.
Exactly. Because so much of the stuff now, specifically with robots, is all about your ability and the psychomotor skills that you can look at something on a screen and superimpose that back to your hand movements to make it work. So anyway, so we watch it on what's called an echo machine. And we go in and we single leaflet capture. So that means that when we get up there, we're not trying to get two leaflets to come together. We can grasp one. And then once we grasp that, we just deploy that and it stays on the leaflet. And then it's what we call forward compatible, which means that if the disease progresses in a couple of years, you can put another one of our devices on, or you can go in using a transcatheter approach and put another heart valve in to the patient. And so again, it helps with longevity. And what we're hoping is as we go through time and we continue to do studies, we see that we can actually treat patients earlier before they get really bad because they have multiple options. And so that they can have this kind of longitudinal treatment, approach to treating them and keeping them alive longer.
Wow. So if it's avoiding open heart surgery, I think people in general are going to be very pleased about it. Right now, where are you guys in terms of bringing this to anyone out there? I'm sure everyone out there is probably like, where can I sign up? So where are you guys in the process?
Yeah, so we're early in the process. So we've put this device in more than 75 pigs, which is always helpful. And our pigs have done really, really well.
And just to be clear, the pig heart is, go into a little bit of the pig heart.
So the pig heart is a nice surrogate. It's very close to a human heart. There's a couple of, nuances, but fundamentally we're able to do pigs and use them as a good, what we call model to a human heart. The difference is that the pig heart has a smaller atrium and humans have a bigger atrium. And that's really important because when we put this device in, we go through the vein, we end up in the atrium, and then we have to make sure that the device is what we call perpendicular to the valve. So you need some room in the atrium to move the catheter because then you go and that's how you get down into the valve and deploy it. So you actually cross the septum of the heart. You make a hole in the heart and cross the septum.
So then it's harder in pigs than in humans.
Way harder in pigs than it is in humans. So that's why we felt so good going to our first human cases. So on February 11th, we did our first 2 human cases in South America. And we just had 30-day follow-up with both those patients, and they're doing really well. They're reporting that their symptoms are less. They're able to walk further. Their breathing is better. And we saw on echo that the implant that we put in is exactly where we put it 30 days later, and there's tissue kind of growing on it, which is what you want to happen.
Wow. Okay. Well, congratulations on that.
Thank you. It's exciting.
From my research, some, experts that from what I've seen said that mitral valve disease is messy. Why do you think they would say that?
Yeah, because your mitral valve is such an important valve in your heart. It's on the left side of your heart. And so that's the most important part of your heart because that's what pumps blood to the rest of the body. And anatomically, people have a lot of different variations in anatomy. And what's really interesting is if you look at the history, so transcatheter, what we call structural heart, right? So transcatheter treatment of heart failure heart valve disease started with the aortic valve, I think 20 years ago. And that's now almost standard of care. And so you're able to treat patients that are 80 years old that would have never been treated for aortic stenosis. So then when the market decided, okay, if we can do aortic valve so well, and this is a big market and a great way to treat patients, let's do mitral valve as well. And I think the number is 40. They call it the graveyard of mitral valve treatments. And so all these treatments came to the market, and really MitraClip, which is the one you talked about, is the one that really survived the test of time. And it's based on what we call a failed surgical procedure or an Alfieri stitch. But no one else has really been able to kind of crack the code. And a lot of it is, if you look at a lot of these devices, the big question is that you have what's called the mitral valve annulus, which is kind of the circle around it. And then you have chordae, tendonae, like there's a lot of structures in there. And so a lot of different companies looked at really, developing these complex solutions that went in and tried to address every component of the mitral valve. And that's why I think people are so optimistic about what we're doing, because it is so simple and elegant. It's saying, don't mess with a good thing. You've got this incredibly complex structure that's working really well. Just fix the part that's not working.
And that's one thing that I read about your company and your founder. What did you say?
Murali Padala, Dr. Padala.
Yeah, Dr. Padala. He was so focused on making sure that his device or his solution was in harmony with the way it was supposed to work.
Exactly.
Is that?
That's exactly right. And, we keep going back to that. We maintain diastole, and that is so important. And then the other thing is he's got like over 100 published papers on this. Like, he studied the space so deeply that his knowledge and expertise about all of these things out there is pretty sophisticated. And so again, don't try to create something that's really complex. Go to the simplicity. And so what we also talk about a lot is 80% of this procedure, what we call workflow, should be what anybody else is doing in the structural heart space. Because if you want the physicians to learn something really complex, it's going to be much more difficult to adopt. So we always say 80% of this workflow is consistent with all other kind of mitral valve devices and even aortic valve devices. And then 20% is unique to our device called the CARLEN. And so we just make sure that a physician can go in, and from an adoption perspective, they can pick up the catheter. It's relatively intuitive. You kind of give them a little bit of direction on, on how it works. And then we make it as simple as possible for that last 20% so that they can just grasp and be out. And that's what's made it really nice, because now we can go in and treat different types of mitral valve disease. So back to your question, we think about it in concept of 3 phenotypes. So ventricular FMR is the most common. And what that means is we call it A2P2 central jets. It's the anterior leaflet in the second position, posterior leaflet in the second position, central, right in the middle. So that's what's being treated today. That's what we can treat. Then you have what we call type 3B commissural disease, which means it's at A3P3. What does that mean to you? It's in the corner next to where all the cords are. So imagine the cords are this jungle of kind of, stringy things that you're trying to get this device into. And so the competition that's out there, A, it's hard to get in there, and B, because you have to get all the way to the corner and then pull from the other corner, it's technically really challenging. So those patients are generally not treated. Then you have what we call atrial FMR, which is a third phenotype. These patients have good ventricles, they're normal, but they have super wide jets. So it's like a big gap from their years of atrial fibrillation. Those are still central.
You're talking about the leaflets. It's
right. So
wide.
The leaflets are really wide, but because we just put one in, we can cover that. Because again, when it's really wide, you're having to pull it way together.
Pull both together, right?
Both together, which means you're coming a greater distance. So you're putting more stretch, which is what's going to cause more stenosis. So that's why we truly believe. And so if we look at from a market perspective, not a patient perspective, from a market perspective, it's about $11 billion market. It's expected by 2030 to go to $35 billion. So that's how many more people are getting this disease. And right now, devices that are out in the market only address about 7.8 billion of that market. And they still only have between 14 and 17% of the share. So there's all the share in that central part of it. Yeah. And then there's, obviously more on either side. So when we translate that to humans and to patients, our ability to treat all of the patients that come in with this disease increases with a simple, straightforward procedure. And one thing I wanted to say too is that when we talk about, the workflow being 80%, why that's really important is because the physician can go in and do that very quickly. So we did 2 patients. The first one took 2 hours, which we expected because we stopped every 10 minutes and talked through it and everything. The second one took an hour. So 2 physicians doing a procedure twice decreased the amount of time. That's how simple it is. By half. So we keep thinking, gosh, by the time they do 5, they should be able to do this in 30 minutes, which means more patients can get treated because they can have more patients come into the hospital on the same day to get this device so you don't have a waiting list.
So if this MitraClip basically adds 5 years, right, in life expectancy, what sort of life expectancy can people expect if they do get the CARLEN device?
What we believe is that it will definitely be longer than that. So without data, we don't know. But what will be different is that they can get a CARLEN. And even if the CARLEN only, let's say, lasts for 5 years, we haven't prohibited them from getting another device because we haven't changed the anatomy of the valve. So they can get another CARLEN. So that'll give them another 5 years.
So they can get a CARLEN on both leaflets?
Yep. They can get a CARLEN on both leaflets. They can get another CARLEN next to this one. They can get a MitraClip if they think that's better.
Why wouldn't you do both CARLENs or a CARLEN on both leaflets at the same time? Just help me understand.
Yeah. So you can do that. And we will probably get to that, but you're always looking to do the least amount with the best result, right? So initially, our device is 16 millimeters in length and about 7 millimeters roughly, and it looks like a football. And so as long as that jet is within that 16 millimeters, you only need one. But if that jet were to be bigger, like in these atrial FMR patients, and maybe the jet's 20 across,
and the jet
we could put
is
two.
the gap.
The gap. The jet is the gap. Thank you for reminding me. And so, so then you could put two to close that gap even better. But the nice thing is that if it comes back again, that's why it's good. Let's say we treated that it was an 8 millimeter gap, and we treated that with one CARLEN, but it comes back, we can always put a second one on. So you have treatment options. That's why we call it forward compatible, which means that it should improve your longevity over time because you continuously have options to treat you as your disease state changes, which in mitral valve disease, back to your question about the complexity, it changes frequently depending on, what your anatomical constraints are, what your disease process is, things like that.
So if everything goes through and some people out there listening are able to get this, what can they expect as a recovery process?
Yeah, so it's pretty quick with transcatheter procedures. They'll go home from the hospital the next day, and then they should be up and walking around. I mean, the only thing, they might have a little groin pressure, but it's a vein, not an artery. So it's generally less pain than if they have
is that where you enter?
Yep, at the femoral vein. And so if they have a cardiac cath, you go into the femoral artery. So they have there's a little more pain there because an artery is just more painful. Veins are very compliant. They stretch. So the device goes in and it just stretches, but they should be up and about in a couple of days and, back to normal activity. As I said, our patients that came in the other day, 30 days, and they're up and about and having a normal life, which is exciting.
Wow. So all of the, kind of lethargic feelings and all the other things that you mentioned early on.
Yeah, should start to improve. And so
pretty quickly. Or almost right away.
Almost right away. It should almost right away. It really is it depends on how debilitated they get. One of the big issues with all chronic illnesses is what's called deconditioning. And so as you get older and you get more sedentary, you become deconditioned. And so as you're more and more deconditioned, your ability to recover gets longer and harder. So what I tell everybody is, don't get deconditioned. Walk every day. Do whatever you can from an exercise perspective, because as you get older and you start to get diseases, that happens as you get older, your ability to endure the treatments that go along with that and recover are directly dependent on your conditioning. So when you see people, it makes me crazy, who retire and then, they sit around and they eat ice cream every day and they drink beer and they don't get out and do any exercise every day. That's deconditioning. And then it's much harder every time you get sick to recover from that.
So any healthy person is going to have an easier recovery.
Exactly.
Just like almost any.
Exactly. And it's like, I think the one thing, and I'm super passionate about this, so I feel like I have to make this point. I'm not asking everybody to go to the gym and do boot camp every morning. I'm just talking about within the confines of who you are, your weight, whatever, like be the healthiest you can be. If that means you take a brisk walk every day for 10 minutes.
Play with your kids or grandkids.
Play with your kids or your grandkids, walk, take the stairs, park in the farthest part of the parking lot. Like they're little things.
That's a hard one for most people.
It's really hard for most people, but you know what? All those little things contribute to deconditioning. And as soon as you're deconditioned, it just makes it that much more burdensome for you to improve from these little things that happen when you get older. High blood pressure, maybe a little bit of diabetes, and they're just little things you can change now that make a huge difference to your ability to live a long life.
It's preventable by being proactive.
Exactly. Without, again, having to do boot camp every day, right?
Yeah, it doesn't have to be anything
right. But people think in extremes, right? We go, oh my gosh, I have to work out. That means I have to do this big workout. No, like everyday walk for 5 minutes.
Oh, I haven't been to the gym in forever.
Right.
And then that's just a mountain that they have to climb every morning.
Exactly. Because you put these kind of constraints on yourself that it has to be all or nothing. And it just is a little bit. And that's how these patients do better, is that if they can stay in some level of conditioning and we can treat them earlier, which is what our true hope is for this device, that we can treat them earlier, keep them healthy longer, and then continue to, intervene as needed, their longevity should not be impacted.
Through Nyra Medical, are you guys doing anything to identify this earlier? I know that your device is CARLEN and fixing the problem.
At this point, we're so young of a company, and we're being, funded through venture capital money. Like we wouldn't invest in that today. Mm-hmm. But my idea, and when I had Dune Medical and we had a breast cancer company, we did a lot of advocacy. So we changed the law in Georgia on breast cancer screening. Like we did a lot of advocacy because we felt that we had an obligation back to our patients. So I have the same vision for Nyra as we kind of evolve and get to the point where we've completed all of our clinical trials and we're, out there, then I feel very compelled that we'll have to give back with advocacy and screening and awareness and all of that stuff.
Okay. Well, that makes sense. On the negative side, what complications can come with the CARLEN?
Yeah. So just like anything, you're in the heart. You're in the left side of the heart. It's kind of an important place, right? It's like, so things like if the device were to embolize, like could that cause an issue? Embolize mean break off and go into the system, and the system being your body. What we've seen is that it generally goes down and not up, which is what you always want, because if it goes up, the only place to go is the brain, which you don't really want any foreign bodies in the brain. It's like one of those things you don't have to know a lot about medical to know that shouldn't go there. So that's one thing. Again, super, super, super rare, if not impossible. And in all of our pig studies, it's never happened. So we don't anticipate that. But you're crossing the septum, and that probably is, so the septum is the difference between the right side of the heart and the left side of your heart. And it's like a tissue, And so when you do that, if that doesn't heal, or if that, like there could be issues with that. Again, it's less than 10% of the time, but certainly that's that. Or you can have a groin complication. So, we're going through a vein. As I said, veins are very compliant, so it shouldn't be a big deal. But we're putting a 27 French, which is a fairly large catheter, through the vein. So there could always be, inadvertent cutting of the vein or occluding of the vein that causes other problems. But for the most part, the complication rates are super low with this. And the benefit, then the other thing would be you didn't get a benefit. So we put the device in, but for whatever reason, maybe we didn't get coaptation, or maybe the patient didn't have a benefit.
Coaptation is the
latching. Bringing it together. Yep.
Oh, the latching.
Coming it together. Yeah.
And okay. And not having that would just be like, what would cause that not to happen? It
would depend on like location on where we put it. So because you're going onto the leaflet, and so we do a lot of planning, which is one of the things that's super fun, is that before the cases, we get a CAT scan of the patient's heart and we print a 3D model of it. And then we take a pig valve and we sew that into the valve place of that 3D model heart. And then we basically put it on a model where we pulsatile flow it and we practice it. So we say, okay, anatomically, can we deliver our catheter through this anatomy? And then we recreate the disease state of the valve. So if the valve has got what we call a tethered leaflet, or a leaflet that's being held back, we create that. And then we can go in and we can try different locations to put our device to see what works the best. So by the time we go do the patient, we've practiced it in our lab a whole bunch of times. And so we should not have instances where we don't get an effect because we're actually trying to get an effect in the lab ahead of time. So we know. But sometimes you get in a real patient and, that's the beauty of all of us, right? We're all different.
Yeah, and it's just the mystery of the medical world.
Exactly.
Right? It's just
exactly.
every environment is a little bit different.
Exactly.
Is there any way that if anyone out there is like, wow, this sounds amazing, is there any way for people to support in any way?
At this point, no, just like if you see stuff on social media, like it and share it because it always helps get the message out there. But so from a process perspective on when this would be available, it's a long FDA approval process, which you would want because we're putting something in your heart. So we will do 8 patients between now and August, and then we will submit for a US, what we call IDE, which is investigational device exemption or early feasibility study. We'll do 10 US patients starting in December. And then from there, we will apply for what's called a pivotal trial where we'll do 300 patients. That'll start in 2026-ish, 2027. And then we'll get FDA approval sometime in 2028. So it's a couple years before this will be available. And then at that point, then people will have access to it. Now, but they'll be able to get in it in a study. We'll probably have, 10 to 20 centers in the United States where people can get access to the device in 2026, 2027.
Okay. So right now, if anybody's listening to this and they're like, okay, I want to get involved. If they want to try and be those 10 people, is there anything they can do, or is that pretty much randomly?
It will be depending on if they're at a center. So we're looking at identifying our centers right now. We know for a fact Vanderbilt will probably be our first center. So if they're part of the Vanderbilt network, and then we're still working through the rest of our centers. We'll have 5 centers on the first 10 patients. Yeah. And then we'll have, as I said, more centers as we go to the next set of patients.
Perfect. Is there anything else out there that I think, of course, they understand where we're at with the CARLEN, but on your side, is there anything else out there that you want to just share about? You have so much experience in the cardiovascular spaces. Is there anything else that you want to share for people out there? I mean, we said exercise, we said, all those sort of things. Is there anything else?
No, I think get screening. I think it's do the basics. It's remember the decisions you're making today don't impact you today. They impact you when you're 70 and 80. And there's no reason why we can't have longevity to 90. Healthy longevity to 90. And it all starts now. It starts at your age. It starts at my kid's age. And it's the little decisions that kind of lead to that. And, my mom just recently passed away and she had right-sided heart failure and lung disease. And she just was a huge smoker. And I, 4 packs a day for 50 years, which is like you basically are smoking constantly. And what I would say to her all the time is, Mommy, yeah, and she was beautiful and skinny and active in politics. And in her mind, she couldn't fast forward. And I said to her every day from the time I was little, it's not going to pack you now. It's going to pack you when you're 70. It's going to pack you when you're 70. And so when she turned 70, she was diagnosed with COPD. So she finally quit, but she went from smoking 4 packs a day to eating constantly. So she gained 100 pounds. So then she became deconditioned from that. And the reason I say that is because when she died, we were very fortunate that we were able to be with her. And we were at her bedside, and I will never forget it as long as I live. She looked at me and she said, "You were right. And I didn't listen to you. I didn't think about how this would impact me at 70. And she said, and I'm so, so sorry that I'm leaving you now because I didn't have to." And that to me was probably the saddest moment of seeing her in her humanity as my mom, because of course your mom's always perfect, right? Even when they're not. But also realizing that those choices that she made were now coming back and she died at 78, which she didn't need to. She had a healthy mind. She was great, but she could not turn that around, So I would just say, take it seriously. The choices you make now impact you later. And that's when it matters.
I heard a quote once that most people say that they would die for their kids, but no one focuses on living for their kids.
Right. I think
No
that's a
one
great one.
focuses on,
Right.
you'll die for your kids, but will you eat right?
Right.
Will you exercise more?
Right.
You'll
Right.
die for them. You'll take a bullet
Right.
for them. Of course you would.
Exactly.
I have a 3-month-old now. I'm like,
Right.
yeah, absolutely. I'd dive in front of a bullet. It's like,
Right.
okay, well, will you skip that,
Right.
bad meal?
It's
Will you
such a
exercise more?
I've never heard that, but I love that because that was truly, that was like my mom, and like I said, at the end, it was really, really hard. And she had a mind like I've never seen, and she should have been dead. And she just had such a strong will to live. And that last week in the hospital, she did everything. And then at the end, it was actually kind of wild because she just was so, so sick. And then she literally woke up that morning and she said to the nurses at 6 a.m., she said, is today Saturday? And they said, yeah. And she said, August 26th? And they said, yeah. She said, oh, today's the day I go. Can you call the girls? And we came in and she said goodbye. And again, she apologized, and I think that was really hard. I'm an adult.
Terrible,
My sisters we're adults. And just to hear her say, I am so sorry for those choices that I made. I shouldn't be going. I shouldn't be leaving you. And she's right. She shouldn't have been. So that's what I would say.
Hopefully the CARLEN can save a lot of people from that situation.
That's what I'm hoping.
And Lori, thank you for joining us today.
Thank you. I appreciate it. It was great.